we are beginning well, honestly, one of the most important lessons in terms of AP Calculus, the beginning of differentiation and understanding what a derivative is. So first off, differentiation deals with a tangent line problem. What is a tangent line? What happens here, we were talking about slope. And what happens is if I have a line or a curve here, and I want to try to approximate the slope of a line connecting 2 points. This is what I would call a secant line because it connects at 2 points. What we're eventually going to look for is to try to get it to be a tangent line, which would be only intersecting right at 1 point. But we start with a secant line because we know how to find slope of that. Change in y over change in x. Well, in terms of function notation, I can rewrite these points instead of y2 and y1, x2 and x1. I can put them in terms of functions, x comma f of x. And if I have this change in x, it could be called c or delta x, then I can change this point to be x plus delta x, and this to be the function of that x plus delta x. And when I do that, I have this very interesting formula here in terms of how to find slope of a secant line. This would be y2, the function, minus y1 over, this is x2 minus x1. And the x's cancel out and gives you just a delta x on the bottom. That's how you find what your slope of a secant line is. Now, what we're looking at here is a secant line, your change in y, change of x to give you a slope. What's kind of cool though is like, well, what if I want to know approximating the slope at this point? Well, if you use a secant line, it's going up like this, but it looks like the graph is more going up and down like this, so it's not very helpful. However, what I can do here is maybe I make this at a smaller delta x, get a little bit closer. Now this is more uphill, which is closer now to what the actual slope would be at that point for a tangent line. Maybe I get a little closer even. Now I'm getting much, much closer in terms of what the slope should be. And I'm going to get just as close as I possibly can, and eventually I'm going to have what would amount to being about as perfect of a tangent line as possible. So what happens when when I'm approaching something, getting as small as I can? That's right, that's taking a limit. We want to make delta x as small as possible. So this is the actual definition of a tangent line. It's the exact same as the secant line, but we want the limit as this change in x goes to 0. We don't want there to be any change in x. We want it to be just one single point where it connects. So how do we do this? How do we find the slope of a function at a point? Well, honestly, this first function right here, we already know what the slope is. We knew this back from Algebra 1. Slope is in front of x. Slope here is 2. Now how do we do that, though, in terms of finding slope for our problem here? Well, every one of these problems always start with what the definition is. The limit of, as delta x approaches 0, of the f of x plus delta x minus f of x all over delta x. Now, we should start plugging in things we know. We know a point, so what I'm going to do is I'm going to plug in this x value of 2. I'm going to plug that in where I see an x. So what I'll get here is just that. I plugged in 2 everywhere. So now, I actually need to evaluate the function. Here's my function. This part right here on the inside is what I'm replacing x with. So, because of that, this first part now becomes 2 times not just x, but this entire part, 2 plus delta x, minus 3, and then minus, what is f of 2? If I plug in f of 2, 2 times 2 is 4, minus 3 is 1. So that's why it's minus f of 2, which is 1. Once you get to this part, it's just simplification. And all we do, what you should look for is something's going to cancel out. And in this case, you see already the minus 4 and plus 4 will cancel out, and I'll be left with the limit as I approach 0, of 2 delta x over delta x. Delta x's cancel out. Now I can plug in 0 for a delta x. Well, there isn't any delta x there. So my answer is whatever I'm left with, which is just 2. All right, now, that's easy for a line. Why would we do all that? I mean, I can just read off 2. However, with this idea, what if I have this, which is a parabola, which isn't a similar or the same slope everywhere? The slope of the parabola here as a tangent line, or here as a tangent line, or here as a tangent line are 3 totally different things. So, how can we tell for sure what to do? There is no one answer, so that's why the limit process needs to work here. So, I'm going to start the exact same way, take my limit of the change in x, f of x plus delta x, minus f of x, all over delta x. And now plug in what I know. I'm going to plug in negative 1 because that's my x value. So the x's here become negative 1s and now I need to see what I have. For this part, x squared plus 1, when I plug this in, the x now becomes this whole quantity. So how that's going to look here, this function is now negative 1 plus delta x, that whole thing squared. Instead of just x squared, I took this whole part and plugged it in. Plus 1 to finish out that function, and then I subtract what is f of negative 1. If I plugged in negative 1, I would have gotten positive 1, add another 1, that's why I got 2. So this is why it's minus 2, because it's minus f of negative 1. Again, all this all over delta x. Just simplifying here, I expanded. This is FOILing here, and that's how I get this as my answer. Things begin to cancel out. My negative 1s here should cancel out. And what I should be getting, I should now have the limit. As delta x approaches 0, I have a negative 2 delta x and a delta x squared up top all over delta x. What I should do here technically, and I should have done it on the one up top as well, I should technically factor out a delta x up top, and I'd be left with, delta x, not just delta x, of a negative 2 plus delta x all over delta x. This way I can physically show for real that I can cancel out these factors. Now, since I've canceled, now I can plug in delta x of being 0. Now I can plug in this 0, and my answer here is just negative 2.